Okay, hi everybody. Just a quick video to show you the project that I've been working on. So this is going to be a static thrust stand for measuring the performance of propellers, which I have one over here. So this is a brushless electric motor. My prop will go on here, obviously bolted on, and what we essentially have here is a tilting moment arm. So the copter will produce a thrust in this direction, and that thrust will be transferred. So there's a rotation axis here. So we have a moment arm of about 18 inches from this line down to the pivot point, and then from this line here, it's going to be about, I have to set it, but it has to be about 9 inches. So that's going to give me a 2-to-1 ratio of the thrust to what I'm going to be measuring on the load cell. Okay, so this is a quick model of the thrust stand that I designed in SolidWorks. So we're looking at a isometric view here, and we can look through the different views. So this is the right view, a front view, top view, and the bottom view. So, and the model is actuable. So we have rotation around this hinge, and as I said before, from a statics equation or a static situation, you will have, let me get this here, the thrust line of the propeller will cause in this case, a counterclockwise moment around this point, and that moment will have to be equal to the clockwise moment that's resisting it, which is up through here. This would be the line of action of the resisting force, and this would be its moment arm. And the equating those two will give me able to, as I said, probably like a 2-to-1 ratio. If this is 9 and this is 18, a 2-to-1 ratio of what I'll be measuring using the transducer. Look at the load cell. So this is just a standard load cell that you would see or get out of any standard kitchen scale, but you can buy them from sources like Adafruit and SparkFun if you want to work on one on your own. So it's essentially a Wheatstone bridge. So it's got 4 wires coming out of it, and it's being analyzed by a Wheatstone bridge analyzer. This one is from Robot Shop, so there's one, you can get it there. SparkFun sells one, Adafruit sells one, so the whole bunch of those. So I've already done a calibration, so it is quite linear. So I essentially made another stand where I put it on top of this, and I tilt it properly. And I essentially put a bunch of masses on it, and I determined the number of grams using a regular kitchen scale, and looked at the voltage output or the configured output as being given by the Robot Shop board. The current from the motors that goes to the motor will be measured using this device. So this is a calibrated resistance shunt, and it has a full load of, at 10 amps, it would give a voltage across these two of 75 millivolts, or voltage change. So I'm going to be able to measure the voltage with that. And the last pieces of the puzzle are a set of IR sensors. So I still need to design the mounts, probably come off of here, and probably mount right here. So every time the blade comes through, it'll break the beam. Maybe it'll probably mount it like that, and I'll be able to look at the signal and get a measurement. So I'll have a measurement of prop speed and current, and the two of those and the amount of thrust that's going. So I'll be able to plot the amount of thrust as a function of current and the amount of thrust as a function of prop speed. So that's the, well, and obviously for the class, lots of 3D printed parts. So I have, this is two pieces put together. I designed it so it would slide right on the 80-20, and I have 3D printed, I guess you call them slot bolts. I'm kind of fond of using M3 screws, so a lot of things have been put together with M3 screws. The hinge piece down here is made out of two pieces. So one that's bolting onto the 80-20, and I have some hold downs also designed and printed, 3D printed, and the last two pieces here are again just mounts for holding the load cell. So you might notice that there's two here. There's only one bolt. The second one is just to provide a little bit more support so that you get a nice even stress of the strain gauge. And this one comes down centered and will be centered right on this. Well, it's actually a little bit off center, but we don't really care about that because we want this line of action. All right, so it's a bit of a statics problem, a bit of an electronics problem, and a bit of an aerodynamics problem. So a lot of fun things all put together there. All right, so I'll shoot another video out when I actually have it up and running and we're getting some data. And this is Professor Sullivan signing off.